few things. It's going to be writing a lab report, and then later in the class we'll talk about reading a journal article. Okay. So has everyone in here written a lab report before? Can you tell me some of your experiences and how would you go about doing one at this point in your education?
First we would write the materials, and then the hypothesis, procedure, and the results and the conclusions. We have like the table and like pictures of you actually doing the experiment.
Okay. Anyone else?
You would also include an objective for your experiment.
An analysis section.
Analysis section. Okay. Anyone else have a different way of going about writing a lab report? Okay. So these are very good. So someone asked me on the first day about the structure, and I told you guys that in college we have a skeleton, and depending on your TA or your professor, you can kind of fill that in or take things out. So I'm going to teach you guys the basic skeleton that you can kind of always lean on. And if your professor asks for something more, something less, then give them that. But you can just kind of depend on this as a reference. Okay? Let's get started. So why is this important? So all scientists do it, even student scientists. So who's planning on going to a medical field or some kind of science field for their career? Okay. So this will be the rest of your life. And no one's going to teach you how to do it correctly. So pay attention, take it all in, because you're going to do it maybe not your first semester, maybe not your second semester, but at some point in the next 4 years, you're going to have to do it at least once or twice. Okay? Okay. So the audience and the scope of the paper. So remember when we first started, I said that your audience was a novice reader. So with your lab reports, your audience is other scientists or your professors or your TAs. So, and this is where a lot of students go wrong. You don't have to go into great depth to explain everything, but the detail must also be there. Is that confusing? So remember when we wrote about our Pepper's Ghost paper, you had to give all the details because I didn't know what you're talking about, your audience wouldn't know what you're talking about. So it's kind of different when writing a lab report. You have to write just enough to be understood, but not to the point where you're driving the point into the person's head as if they don't know what you're talking about. They want to know what you're talking about. Okay? Alright. So the idea is another knowledgeable scientist will be able to read and redo your experiment. So that means that you have to be detailed enough for them to read it and use your paper as the procedures, if you will. Okay? It must be well written and understandable. Because you're writing with the intent of someone to redo your experiment, it must be well written to the point where they can read it word for word and actually replicate it without any mistakes or questions. And it pretty much outlines your project or your experiment. That's the purpose of it. Okay, so here's the parts. You have the abstract, the introduction, materials and methods, results, discussion, and references. So this is your skeleton. This is what each portion of the paper is. This is the skeleton I was telling you guys about. Use as a reference. Professors may say, I want an additional part, put it in there, but for all intents and purposes, this is what you're going to use. So we're going to start with the materials and methods portion as well as the results portion. Do you guys know why we start with that, not the abstract first? Any idea?
Isn't like your abstract the summary? So you have to like do the core parts first and then write it. To write a good abstract, you have to do the core parts first.
Okay. So why not start with the introduction? Anyone?
I guess because we have to go through the experiment and fully understand what you're doing to be able to give a proper and thorough introduction for the reader.
Okay. Okay. So, the materials and methods is considered your starting point. It's considered the most, or the least effort, it's considered the effortless portion of the paper. So the materials and methods is pretty much restating what you did. So you don't have to go out and do any extra research. You don't have to formulate anything special. You're just writing what you've done. So you tend to start with that first because it's the least, the part of paper that requires the least effort. So what you pretty much do is you restate the procedures in your own words. The purpose of that is to explain how the experiment was done so that other scientists can review your experiment. So this is like the meat of your paper. Everything else is important, but this is the important part because this is the actual experiment. Is that clear to everyone? Okay. So I gave you guys an article, and you can kind of use that as a reference. So if you will, go to the methods portion of that paper. Everyone get one? Which one do you need the article? Pass this back. Okay, did you guys find the methods portion? Anyone? No one found it? Okay, so where is it?
Third page.
Okay. Does everyone see that? Can you like read like a few sentences? You can kind of see what I'm talking about as far as the experiment. It's in that part of the paper. You guys read a little bit of it? I got a feel of it. So the materials and methods portion is where you actually describe your experiment that you've done. Okay? So in this portion, you must include all measurements, conditions, and type of tests used. So what's the goal of this portion again? Anyone remember?
Explain how the experiment was done.
Hmm?
Explain how the experiment was done.
So that
Other methods,
right. So with that being said, you have to include everything, every single thing that you've done. So when you're in lab, it's going to tell you pour 1 to 5 milliliters of water into the beaker. If you poured 1.5, then you put 1.5. If you poured 2.5 or 2.33, then put that. You can't put 1 through 5. This is where accuracy comes into play. Okay? So everything that you've done, every little thing. It must be in complete, well-written sentences in paragraph form. So in high school, some of you may have written this portion in bullet form. Anyone did that in high school? I know I did. I'm gonna raise my hand. Okay, so no more. You're gonna write this in well-written sentences in paragraph form, like they did in this paper here. Okay. Concision is key. So the important part is you have to know what information is important and what is not important, and include only what is needed to reproduce the experiment. So I know also in high school you may say, I went to the computer and opened Excel to do a graph. I took a picture of the cells. Anyone did that? Yes, no, I know I did. I'm gonna raise my hand, to be honest. Okay, so that's not very important in your actual experiment. Everything that you do to prep for the experiment, everything you do to record the experiment would not go in this portion of the paper. Is that understood? Any questions about that? Yes.
Is it also for the materials that you have to write, like, you will need, like, whatever the material is, or can you do that as, like, a bulleted list?
Neither.
Okay. So, good point. In college and beyond, you do not list the materials. Anyone want to fight about that? Any questions about that? So, in grade school or in high school, you would list scissors, glue, thermometer. You wouldn't do that in college. You would simply state what you've done, and those materials would kind of come into play if it's necessary, and we'll get to that point later, okay? Any questions about this so far? All right, so the most important thing about the paper, and we discussed this last week when we were editing papers, is that the materials and methods is written in the past tense. So you would see as we cover the whole paper, different portions are written in different tenses. Is that confusing? So, you look confused.
Yeah.
this portion is. The introduction is not, the conclusion discussion is not. But this portion of the paper is written in past tense because you've already done it. Any questions? You guys ask questions. I see confused looks. Alright, so I put try not to use the first person, but in reality you will not use the first person. You will not say I measured the water, I boiled it to 70 degrees. Like you won't do that. You will not use I. And for that reason, sometimes it will sound passive, and in this case, it's okay. Question?
What about we?
No. I, we, you, us. No. No pronouns or any other word that kind of alludes to a pronoun. Another question?
No, it's more in your statement A, you, we on the first sentence of your review. Be conducted in one. I was just asking you this thing.
In the materials and methods portion?
Yeah, on the overview. The
Okay.
very first.
This is where it gets confusing. For your purposes, you will not use we. These are scientists who have been in the field forever, and in these papers, they will write that way. You will not write that way. You have to kind of know the rules and be established to break them. You guys don't know the rules, so you're not established enough to break the rules. And when your professor reads these papers, they're not going to want to see we, I, us. It's not how it goes. Any confusion?
That is a perfect description of exactly what she just said. You guys are never to use, write down never to use I or we. It's one thing if an established scientist does it, and usually you'll see them do it one time, if they do it at all, but that's it. First, next, and finally. Those will become your favorite words. That will describe chronological order, which I know you were getting to, so I'm not going to say too much about it. But that's how you move yourself, because you're doing this in chronological order. That's how you will describe your methods.
But in scientific writing, you don't want us to use chronological order. Like you don't want us to use first and next.
You shouldn't rely on it.
No, you shouldn't rely on it.
Sometimes you get those sentences that's kind of awkward if you don't use anything else but that.
Right.
But for your purposes, keep in mind that it's in the past tense, and we already know when we're reading it that we're reading it in the order that you did the experiment.
Right.
So don't rely on it. If you have to use it, then do, but don't say first, then secondly, thereafter. You can't start every sentence like that.
No.
But you can in lab reports, but not in scientific writing.
Same rule.
Okay.
Yes.
How does it work for transition words like therefore and however? Are we just supposed to avoid those?
Give me an example. 'Cause I hate to say yes and exclude it altogether, but then there are some cases where it would be appropriate,
Right.
but I wouldn't depend on those words.
Okay.
I wouldn't say exclude it altogether, but I'm also saying that don't depend on those helping verbs or helping words to kind of save you everything. You have to follow the rules, and if you need it, then throw one in there every now and then, but don't rely on it.
Therefore and however also imply that you're about to do some sort of analysis. That is not what this section is for. Don't do any don't explain why you did what you did. That comes later. So those words tend to avoid them because they will lead you into a path that you don't want to take, and then you have to rewrite the whole sentence.
And guys, just as a side note, this is a hard concept to grasp, writing a lab report. I remember my senior year in organic chemistry lab, I had to rewrite a lab report 5 times. 5 times. Because my TA didn't like it. And you will find it in college, your TAs will be your toughest teachers versus your professors. And they will be very hard on you, just as the word to wise. So they may ask you to rewrite something a lot of times because they know the correct way to do it, and they're going to push you to do it that way also. But long story short, he couldn't really tell me what I was doing wrong, and he wouldn't sit there and explain to me what I was doing wrong. He just said it was wrong. He didn't give me a format, and he was going to give me a format, it was just wrong. I had to rewrite it 5 times. And even that 5th time was like the end of the semester, and there was no more time for me to write another one. That's why I was 5 and not like 6 or 10. So ask questions. It is daunting. It is difficult, but it's doable. Okay. So another rule is don't state the obvious. So you're gonna avoid stating common lab procedures. And I have some examples here, like use the beaker, calibrated the scale. Those are things that a scientist would know to do. So if you wanted to say, I boiled peroxide to 75 degrees, you wouldn't say in a beaker on a Bunsen burner. You wouldn't use those words. You wouldn't use lab material words like beaker and Bunsen burner and graduated cylinder. What are some other ones? You guys know some other ones? So much. Glass, crucible. I measured it with a ruler. How else would you measure? We know you use a ruler, obviously. I weighed it on the scale. You wouldn't use that. Just say the substance was weighed. You don't have to say it was on the scale unless it's very important to the experiment. Unless using a digital scale versus a triple beam scale is important to the experiment, then you can put it. If it's not important to the experiment, if it's not going to change anything, don't put it. Question.
What happens if you need to be specific? It's like, what happens if you're reading it, like, I weighed it, and you feel like, oh, more like,
If a person did something different and it would change the outcome of the experiment, then you would state it. For instance, some things cannot be put into a glass container versus a plastic container because you would degrade the plastic container, not the glass container. If that's important to the experiment, then you put it. If it doesn't really matter, then you wouldn't put it.
Generally, if your analysis requires that you do something, like if you weigh out 0.75 grams of sodium chloride and put that into a solution, I don't need to know that. I need to know that you made a 0.5 molar solution of NaCl. But if your analysis required that you measured out what the product that you got, that's when you tell me that you weighed out, or the how you weighed out your materials. So if analysis requires that you do it, then you can put it in. If it's going to be in your results, then you need to put it in your methods. But if it's something you did to prep for an experiment, get ready, stuff like that, you don't have to put that in your methods.
Any questions before going forward? And you also don't include stuff that you did outside the lab. So I know in high school we do this a lot. We'll say, I went to the library and researched for 3 days to find out this information. If you did it outside of that lab, you don't include it. So I have some examples here, making a graph, read background information, took a trip to botanical gardens. You wouldn't put that. Is that clear? Questions? Okay, so I had a little activity. I don't think you have the time today to do it, so we'll just move on. Okay, so any other questions before I go on to the results portion? It's written in chronological order, so you're not going to write it outside of the order that you've done it. Write it just as you did it in the lab. Okay, so the results. The summary, the results is a summary of your findings, and where people get confused is the results does not explain the findings. It pretty much just tells what the findings were. So if you put, let's see, yellow and blue together and made green, you would simply state that yellow and blue makes green. You're not going to explain why it makes green or how you feel about the fact that it made green. You're just going to state that it made green. Is that clear?
So guys, it sounds clear now, but I can promise you it's not. This is one of the most complicated and hardest things to get into your head, is that you do not want any analysis in your results at all. All you want is to state what the results are. It will be fighting your brain to not put an analysis in, to not explain why you're doing what you're doing. Remember I said that in the fall when you're writing your first lab report.
And the same thing goes for your methods and materials. You're not going to explain why you're doing each step. You're just going to tell what steps have been done. Okay. All right, so this is what you don't do. You do not simply transfer all the results from your lab notebook to your report. It also has to be written in well-written sentences in paragraph form. So you're only going to include data that is important, and you're also going to exclude things that are incomplete or that did not come out right. So sometimes, all the times in lab, you're going to do experiments where it didn't come out the way you wanted it to, or something spilled, or something boiled over and burnt. You're not going to put that in your lab report. Is that understood? Only thing that you've completed successfully goes into the paper. In your discussion, which we'll talk about later, you can talk about those things that you messed up on and your future endeavors in that experiment, but in the results, you're only going to put the things that came out right. Alright, so as a rule, the results should have text and visuals. And sometimes in lab you may not have any visuals. As I know sometimes in bio you might have pictures, or in Orgo you may have structures. You can include that if you can explain it. So the text must explain what the visuals show. Visuals are not just for aesthetics. It's not in there to make it seem better. It's in there to explain your point in your experiment. So you're not going to put any cute structures. You're not going to put any cute butterflies if you're in biology. You're going to only put images that refer to your actual lab. Is that clear?
I don't know what she's talking about. So what does it mean that visuals must be labeled properly? How do we properly label a graph? So it has a title,
All the
axis.
pieces must be in
Labeled
that
axis.
paper, because that's part of the reason why I had to rewrite that paper a lot of times, because my graphs weren't labeled correctly. Which seems silly, but it's very legit.
Which axis do we label? Maybe both, Sergio?
You have your dependent and independent. So your independent would go on your x-axis and your dependent would go on your y-axis.
So you label your x and y axes. What else do you have to label? You've got a title. You've got
Interval.
labels. Who else?
The measurement.
The measurement that you use should be in there. What else? Cooper?
Sort of bar graph, like what each color for the bar's name.
Okay, we call that the key or legend. So that goes in there too. Anything else? Yeah.
Label on the axes, which one is the independent and the dependent variable?
You just label them themselves. You don't tell me if it's independent or dependent. I don't care. But you tell me what the actual item is that you're measuring, and you give me the units that you're measuring it in. What about if it's a table? What do we need for that?
Have the units that you use. You have
The
to-
units that you use for what?
For whatever measurements you need, but not in the columns themselves, but like at the top.
Above each column should be the units that we used. What else? Other than Sergio. Sergio rule. Nope. Don't care. I assume you know independent from dependent. What's in the column? How do I know what that column is?
The order, like
The label.
1, 2, 3.
I label the columns. There we go. So I need to label the columns. It sounds obvious, guys. It will not be obvious, and your TA will not tell you did it wrong. They'll just put a big X through it and give it back to you 5, 6, 7 times, or never give it back to you again, and you'll wonder why you got a C. So you need the measurements that you use to measure whatever it is that you're in: meters, nanometers, liters, moles. You need to label each of the columns. You need a title. And you need a caption. What's a caption?
It describes.
Do you believe that?
Yeah.
Okay, say it loud then.
It describes what's in the table or graph.
It is a 1 to 2 sentence summary of what's happening in that figure. It's not an analysis. You're not explaining the details of it, but you're giving a summary. Anybody else? What about a diagram? Sorry. This is the part, guys, I'm going over this because this is the part that I always take off on. Because you guys like to just throw a graph together and not explain anything about it. Jessica, anything you want to add? For a diagram. Title. Chrissy, you know you want to add something, I could tell by the back of your head.
Label the parts or whatever the diagram is.
Always label the critical parts, and I'll know that you know what you're talking about if you label the right critical parts. That's what I'm looking for. I'm not looking to see how pretty it is. I'm looking to see if you label the stuff that actually matters. Ash?
If you have a legend for a kayak.
A legend, if you have something like that. And what's the last thing that you do? Talia said it before. Caption. Always put a caption. Okay?
I
Yeah.
have a question. What if, well, I guess not really in the results part, but like for the analysis part, when you're trying to like cite, I guess, a picture, or you're trying to reference it in your paper, like to maybe help further explain it. Like, is there a certain way you're supposed to cite it in your paper, or like make a note that it's there, or would it just
So-
throw the note?
You mean for the picture
Yeah, like or a graph or something.
to cite it?
Not like literally cite it, but like if you wanted to include a reference of it in your paper to like maybe like point it out.
Refer to table 1.
Yeah.
Refer,
Yeah.
You'll simply put refer to table 1 or refer to figure 1.
Yeah.
But you can't just put refer to table 1 and not explain anything and then put a period and just move on. You have to explain why that picture is there, why that chart is there, why it's important, what does it say. So, all in all, if you're going to include visuals, the text must come along with it. The visual cannot stand alone. You have to describe it in your caption and in the actual body of the results section. Okay? I just went over this. It must be properly labeled and easy to understand. In real life, journal articles have tons of charts, pages and pages of charts. In college, you probably have no charts or 2 charts or 3 charts. So don't feel bad about not having a very lengthy results section because sometimes there's just not a lot of information to put there because you're actually just simply stating the results. It's not as long as your discussion session or your methods and materials. So don't feel like this evil being upon you because you didn't have a long results section. Just state it, put the pictures in if you need it, if not, exclude it, and move on. Any questions about that? Okay. So, the visual, like I said before, I just want to stress this, that visuals cannot stand alone. We have to describe it in the text. And you can say, you can explain something, then you can say refer to table 1, and then you have the table there with the caption to bring it full circle. It must have those 3 components. The visual, the caption, and the text. Yes.
When you're putting the figure table in the results, you put it on the back of the page or
No.
how, where would you put it?
No, you include it, just put it there and include it. You can look actually in your example article. They actually put their pictures in the back of the paper. I wouldn't do that. I would put it there with the text. Like I said, they're pretty much established. They can do what they want. But
So like in figure 1 and then explain it and then right after it you have the table.
Well, figure 1 should be on the page that you explain figure 1 at. So if you start talking as shown in figure 1, comma, you tell what you want to need to tell about figure 1. Figure 1 should be easy for me then to find in your text on that page or the next page. Word makes that very easy. Insert picture, crop it tight, tell it you want tight spacing. Boom, it does it. It'll even let you put in a caption. It'll take care of formatting the caption for you. It makes it easy.
so don't use, if your professor said that your lab report has to be 10 pages, don't use a page or 2 just for pictures. Do not do that.
I would hurt you. Yeah, that, no.
It has to go within the body.
Yeah.
Question.
So, say we did have pages for illustrations and visuals, those would not be included in the 10 pages.
Yes, you should assume so. I would say to include, if the picture is just too big and too detailed that you can't put it in the body of the text, and you want to include it maybe in the back, then that's not included in your 10 pages. Don't do that, guys. It's like the
If you put too many pictures in your lab report, your grade starts at a 6. That's where you start. And they don't give too many A's around. Like, it has to be distinct. So you're starting at a C. So if you're starting at a C, that's a do-over. You have a good professor or TM. So.
And don't try to fake me out with a full page graph when it doesn't need to be full page. If you're trying to show me a single curve on a graph, you can have that done in a pretty small amount of space. I don't need a full page for that, and then for you to say that's one of the 10 pages for the lab report that I assigned you. Put it in the text, move on with your life, keep talking about stuff.
Any other questions about the visuals and the results portion? Okay, so now I have time to the handout. So this is a perfect example. Sometimes what we can say in words is better understood in graphs, so don't exclude it all together. So I want you guys to read this and tell me what I'm trying to convey here. Take like 2 minutes to read it. Can anyone tell me what this is about? At all? Anyone interpret this? No, not really. What if I put it with this graph?
Sergio's hand is up.
Oh, go ahead.
What they're talking about is the concentrations of 2 different plasmas, albuterol 4, albuterol 4 milligrams, and albuterol ER.
Albuterol.
The first paragraph is mainly talking about the fluctuations and the concentrations of the albuterol 4 milligrams.
Albuterol. Okay. Albuterol.
Which rises to 13.5 nanograms in 2.5 hours. So on your chart, you will have a fluctuation at 2.5.
But could you tell what it was without the chart?
Yes.
Okay.
And then as you proceed on and your time increases, it will decrease once again to 9 nanograms, and then once again increase to 12.5 at the 10-hour mark. So without looking at the chart, you could, if you visualize it, it looks like what I always think of a roller coaster. So, or sine or cosine. And then albuterol will maintain nearly the same concentration throughout, and then it decreases to 9 nanograms.
So what's easier to understand? The chart with the words or Sergio's explanation of the chart?
Which do you think a professor wants to see? Chart.
The professor's not gonna take the time to sit there and draw it out or visualize it.
Nope.
They're just gonna assume that you're just using up space, and they're gonna move on, and they're gonna count off of that. So this is an example of why text and visuals are important to convey your point, because if you just took each one to stand alone, it wouldn't be valid. Question?
Yeah. Like when you're doing a lab report and you have your chart and the words like this, is it like the paper, like you're writing, and would it look more like this? Like the picture would be over here and then the words? Or
You can, the format doesn't matter as long as it's maybe below, next to, but you can't put it 10 pages down and expect them to look for it either.
but I'm saying like, where?
What's your question? Don't say
No,
oh yeah.
I'm
It's
clear.
clear. It needs to be clear.
No, I was saying, okay, like, if I'm writing, like, okay, if it's like all these paragraphs, and then I'm still explaining, and then I put a chart. Like, does it matter if I just have the picture here and the words continue right here?
Yeah.
Or should I like finish picture and then?
You should anchor the chart to the paragraph that you're talking about. If you're thinking about it in Word, how Word likes to anchor things to places, the chart, which table, figure, whatever you're talking about, should be anchored within the table within the text that you first address that figure. So, as shown in Figure 1, boom, you can start talking about that. Anchor it to that paragraph.
Alright, so reading the charts. So you have to label your chart so that people can understand what the chart means. I know I said that the charts and the words can't stand alone. However, your chart have to make sense. Okay? So can someone kind of interpret this chart and tell me what it's about?
As time increases, the concentration decreases.
The concentration of Truvada. Okay. Anyone else? How would you describe this chart if you had to write about it? In your caption or in your text? How would you describe this chart? How detailed would you be? Okay. Anyone else want to add anything to that? I like it.
I was going to say inverse correlation. So as time increases, concentration decreases.
What about the actual concentration values? Would you include that? Would you include that it starts at 30 milligrams per liter at time 0?
In the caption.
Was that too much detail?
I think that's too much
Everybody
detail.
can see that for themselves. I don't know, would the professor be able to see that for themselves, that they can see that it starts at 30 at time 0, or do you have to include that?
You have to include it.
This is for the caption or just for the document?
For the caption, you don't have to include that much detail, but if you're going to discuss it in your text, you have to include that much detail.
Even if it's obvious.
Even if it's obvious. Yes. It will, because if you don't explain it in your text, they will think that this chart is random and that you don't know what it means and you don't know why you put it there. You just put it there and you didn't address it in your text, so it's just a random chart. Question.
So in your caption, you would not have to include the starting concentration, or which?
Your caption is kind of like a summary. It's 1 to 2 sentences, so you can't really put all of that in 1 to 2 sentences. It's pretty much just a summary of what you're looking at, but in the body of the text, you do have to explain that. Right. Otherwise, it's just random.
Can you go back to that one more time? Sorry, there was just something else. So how do you know, all of you said that over time it decreases. What happens at 13 hours?
Would you say on this interval of time?
What's the interval of time? Do I need to go look it up?
0 to time 12 hours.
Over a course of 12 hours, then that's what you'd say. That keeps you safe for if this happens to jump up at hour 14, it could happen, you're safe. Also, is this concentration in water? Is this a solution?
And blood.
Blood. That is something specific that I need to know because that's a totally different environment that it's sitting in a beaker in the lab. Be specific. Start thinking specifically.
So you're referring to the caption where you...
And the text too. It should that information should be in both.
Okay.
But again, the caption is 2 sentences. Not 2 mile-long sentences that end up being basically the same length as the results, but 2 sentences. It's all about specificity, and it's hard. Sorry.
All right, so we're going to move on to part 2, which should be a little shorter, a little bit more simple to grasp. It should be like the next page. So, we discussed the materials and methods in the results section. And like I said, I would suggest to you to start writing these sections first because it's basically what you did, and then start with the introduction, discussion, and then your abstract and then your references. So this is the way it should be listed in your paper, but it's not the way that you should begin to write it. Is that understood? My high school students really get confused about that. Just because you started with materials and methods doesn't mean that's the first thing you put in your paper. The first thing is your abstract. Okay? So we're going to go over briefly the other parts of the paper so you will understand how to do those. Okay, so discussion. I put discussion next because after you write what you've done, this is the part of the paper where you can kind of discuss what the experiment was about, kind of your input. I know the first day I said that scientific writing is objective, and you just simply state the facts, but the discussion portion is kind of where you can put your own thoughts and your own opinions in there. I'm not saying to put this was interesting or I like this experiment, but I'm going to explain it. You'll see what I mean by your own opinion. Okay, so this is a portion of the paper that interprets your results. So remember I said that materials and methods and the results section, you simply state what happened or what you observed. In this portion, you can interpret or you can analyze what happened. Okay, this tends to be the most lengthy part of the paper. In some journals, if you will see, a lot of authors take a lot of time to explain themselves or to talk about things that went wrong, things they want to do in the future. This is the portion of the paper where they would do that. Okay, so the main question of the discussion section is, what does this all mean? Why do we care? What is it? Do I have a hand raised in the back? Yes.
In the discussion part, can we still not use first person?
Right. No first person. But it is present tense. So remember I said that methods and materials is past tense. This portion is present tense. I know it's mind-blowing. Same paper, two different tenses. That's how it is. Question.
I know we're not there yet, but on the abstract, when you're splitting it up, because I know you're going to have to write about, summarize the method and results. Is that going to be in past tense?
Any other questions? All right. So I gave you a few questions to kind of put in your mind because you guys are not experienced scientists, so sometimes it's kind of hard to know what to write about in your discussion. So I gave you a few pointers to go off of as a starter. So you want to describe how the results relate to your background information. So as we get to it later in this presentation, your background information is pretty much what we know already about the subject matter. If we're studying Pepper's Ghost, you would pretty much put everything that we know about it now in your introduction. In your discussion, you will relate what you did in your experiment, how it relates to the background information. Why is this important? What does this experiment prove wrong or right about what you already know? Okay? Do your results agree with your background information? If not, you can discuss possible sources of error. If you were supposed to boil salt water for 5 minutes, and by the time you got 3 minutes, it all evaporated, you can discuss why it did that. Okay? So you can put that here. You can also describe inconsistencies. If you do your experiment and it didn't turn out the way you thought it would turn out, you can kind of explain or discuss something that you may have done wrong, or why you think it didn't come out right, or what you want to do in the future. You also want to discuss things you want to do in the study in the future to improve upon it. So for your purposes, you won't be doing these experiments over when you're in ortho lab or bio lab, but you would say, if I had to do it again, we're not actually those words, but if you had to do it again, what would you do differently? So those are like some good starting points to start off your discussion. Any questions about that?
Let's talk about sources of error, which you always put in high school. So Jim,
Human error.
if you ever say that in a lab report, I will come to your house. Not your dorm room, I'll come to your house. Don't say that. If you made a mistake in the lab, then you should take the opportunity to fix it while you're in the lab. If your lab partner decided to put their finger in an experiment, that's when you can say they did something wrong. You should go back and fix it. You should go back and make it right. Don't use human error. That tells me you're sloppy and you don't care. Now, if you know after the fact that it said to put in 0.1 grams and you put in 1 gram of something, after looking back at your lab report or after looking back at your lab notebook, okay, tell me that. But then go on to tell me how you think that mistake messed up the lab. Don't just say, I did this and it was wrong. I'll tell you when it's right. So put in why the mistake occurred, what happened, if there is one, but really there should never be one. You should be paying attention in the lab. You should know what the experiment is before you get to lab.
You guys know this. Let me just interject.
Yes.
That you're not the first set of students that have completed these labs. Like, you're the probably million labs to complete
Yeah.
these labs. So labs don't change.
No.
The professors and the TAs may change every 10 years or 15 years, but the labs don't change for the most part. So know that. So, you know, the expectation is pretty, we're looking for the same outcome, but we're looking for it to be written properly. So they're really sticklers for it. So like for them, it's like reading a Dr. Seuss book, like reading Cat in the Hat. Like you pretty much know it after you've read it so many times. So they will make you rewrite it. And if you don't rewrite it, shame on you. So like, this might not be the most favorite part of your day, but you need to pay attention and you need to take notes because everybody doesn't get this. And the whole purpose of us even implementing this part of the program is because there were so many students struggling with scientific writing. It's just a hot mess, for lack of a better term. It is a hot mess. And I don't like to see students write.
No.
So, and I get the babies in my office. This is when I mess up. So, if I see you in my office, you get no mercy from me because you have the upper hand. So, you need to really put pen to paper and take notes and ask questions because it's very serious. It's ugly. You know, when August comes, it's ugly. It's not pretty. This is fun. August is ugly.
August is ugly.
It is. And they're not going to tell, she's not going to tell you that, he's not going to tell you that. But I'm going to tell you August is ugly. So, I'm sorry. This one.
The other thing about this is the discussion section is the hardest to write. It is hard. You have to think about this stuff. You have to actually think about, now I got to combine my methods, I've got to combine my results and my introduction into something that sounds scientifically valid and that actually joins in with what we've learned in lecture, what we learned in lab, what I know about science. It takes time. We want an interpretation that is more than the bold-faced words in the book. This is where you get to interpret your results. Without using I, me, or we, which is so much fun. But it's hard. It takes time. But if you do it well, it tells the professor, hey, this person might be ready for research in my lab. This person might be ready for something else. It might be, I want you to come back as my SI for next semester. Something like that. That's where they see these things at. That's where they see if you can think about what you've done. But it is hard and it does take time.
It also shows that you don't understand the material.
Yeah.
Because every other portion of the paper is easy. I mean, the abstract is a summary. The introduction is just a summary of background information. Methods and materials are pretty much your procedures, but in past tense that you, and something that you actually done. Results is kind of, I mean, it's pretty easy too. But this portion really shows that I don't understand what I just did. And it'll be a total waste if you just did all that information, all that work, just to get to this portion and just mess it up. So with that being said, make sure you understand your lab before you go to lab. Make sure you understand what you're doing. Ask questions, ask how it relates to what you already know. And this is like the portion where in lab, when I was a student, I realized I really don't know this material. I really don't know what I'm doing. And you should ask questions based on that.
So how can you make sure you understand the lab before you go to it? You can read. Say again?
Read the book.
Read the book.
Ask questions if you have to.
Ask questions. Who are the best people to ask questions to?
Your professor.
Ask students.
Better than them.
The TAs. Ask each other.
You guys are all in this room right now. That's one of the reasons we wanted you all to come here so you can meet each other. So when you're in 141 and you go, what is our lab today? And then you laugh and look at Ash and go, didn't you read it? Of course I read it. Let's talk about it. Talk about it. You're lucky. So that's what you need to do, is you need to talk to each other about it. You are now a perfect set of study groups. If you talk to each other about it, you will know it so much better than if you just read it in the book. The other thing that I want to tell you about is when I'm reading lab reports and grading them, what do you think I read first? One before that. No. I read your results first. That's the first place I go. I don't even bother with the rest of it. If I go to your results and I see that first of all they're off and they don't make any sense, then I start to laugh, and then I go to your discussion. And then I see if you made any sense. I'm just telling you the way we do this. This is the inside track, guys. I'm just telling you. I laugh because I know what you should have done in lab. And then I look at your discussion. Did you make sense of the mistake that you made? Because I can tell when you make a mistake. I know what the graphs are supposed to look like. I know what the table should look like. I've done these labs before too. If you don't put any discussion into it, if you don't try to explain it to me, I don't have to read anymore. I don't have to bother with all the other stuff. It can be as pretty, that introduction can be as pretty as Kimbria has told you guys 50 times how to do it. I won't bother reading it, and it took you hours to write it. I don't need to read it. I already know you didn't understand what you were doing, and you couldn't explain the mistakes that happened. Boom, there's your grade, and I can move on to the next one because I've got 35, 40 of them left to go. Miss Neal?
Oh, it's the app. The grade for that. One shit.
Yeah.
Like you did all that work for nothing. And you wrote it out. You got to do that. So, you got to go ahead.
Yeah.
Any questions about the discussion section? Yes.
So is there like option credit for it kind of like even if you're
Not really. I mean, if the results are messed up and you can explain why they're messed up and you don't use human error, I'm kind of okay with it, but I'm probably going to ask you to rewrite it. I might even be generous enough to give you a good set of graphs and say rewrite it off of this. If I'm feeling nice and generous. Otherwise, partial credit, not for this. It's either right or it's wrong.
So the best thing to do is just to be able to explain yourself and know your
Yeah.
mistake and write it.
Exactly, because what that shows me, exactly what Ash said, what that shows me is that you're thinking about it. That's what I want to see. I want to see that you're thinking about this little tiny lab for more than an hour in a day. I want to know that you're thinking about it, and I want to know that you can take something that we did, something that we talked about in lab or lecture, and apply it yourself. Remember the test questions that Dr. Calabrese showed us on Monday? They weren't definition questions. They were application questions. They were, how do you take the knowledge that I gave you and apply it to a different situation? That's what the entire purpose of a lab is to get you to apply information to a different situation.
And that's pretty much how science is going to be at Emory. When I went to pharmacy school, I was so relieved to have multiple choice questions because for 4 years I did not have multiple choice questions. Maybe I would have like 6 that were really easy at the beginning of the test, and after that it's a 12-page test, and it's all like open-ended. Every single last question. So and even in your labs, it would be that way. I was so relieved to see something that was multiple choice. I was like, thank God, because at Emory it's not that way. Maybe in bio, but it depends on the professor and the TAs. So you have to know this stuff, guys. You just can't, flash a pretty smile and get away with it. It doesn't work that way. You have to know it.
Because they flash back at you.
Mhm.
We can see you. Sure, we can have coffee. I'll have coffee with you.
Yeah, I'll still give you an F because
Yeah.
I still have a standard that I have to be held to.
Exactly right.
I have my standard that says this is because in an intro class, I know what you need to know for the next 3 years to get through. I need to know that you know what's going to happen next and that you know the right concepts. If you don't know the right concepts, I'm not doing my job by giving you a good grade. I'm not helping you at all. I'm actually just spending yours or your parents' money at that point to get you to the next step. That's not fair. That's not fair to you, and it's not fair to me because I'm a scientist and it took me a damn long time to get my degrees, and I know what I had to go through to get them. So I expect you guys to do the same thing, and I expect you to do it well. So that's how it works. Sorry.
Don't be scared, guys.
Nah, you'll get used to it.
You'll be fine.
No, just be serious.
Yeah,
Serious.
serious helps.
So your introduction, we all have done an introduction before. It's pretty much you go, you read information, summarize it in well-written sentences. It should make sense. And the same rules that apply to our summary that we did the first day apply to the introduction. It's also written in the present tense. Okay? So the purpose of the introduction is to give historical or background information about the topic. It should give an idea of what motivated the study. The purpose is written in the introduction. It's usually like the last sentence of the introduction is usually what the purpose is, but it answers the question of who cares. Why are we doing this experiment? Why are we wasting money to do this experiment? Why are we wasting time to do this experiment? Your introduction should explain why. Why are we doing this? What do we already know about this? And how does this experiment link to what's important about this topic? Okay? Generally, and I don't know if they want you guys to do this in college, but you would use scientific journals and review articles for your background information. So this is where sources come in. Most times in your labs, you will already have information about the topic. If you want to bring in any additional information, it has to be about the source. Your textbook, okay, I guess, things to be defined. But if you want more current information about the topic, you have to use certain articles. I'm not going to go out and say do that for everything, but I would just say ask your professor about what information and what sources they want you to use. Yes.
I guess I have a two-part question. So when you say that you're already probably going to have background information from your lab before you actually do the lab, are you going to cite that in your introduction? Say they give you like what kind of information are they giving you? Is it
Usually with your labs, they would give you like a little blurb about whatever you're doing. Sometimes they don't. I know in Orgo they don't. So sometimes, and I think Orgo lab for me was like the hardest lab, number one, because it's a separate class. So they expect you to know a lot. But they don't really give you a blurb about what you're doing. It's just experiment one, do this. And you have to go back and actually research this topic and actually know what the topic is, what the experiment is about. So when you're researching that, I would just say ask your professors what sources they want you to use for your introduction. The standard is journal articles, but for college level, I'm not sure what they expect from me. Different TAs would expect different things. Any questions about that? Wikipedia is not a good source. I'm just gonna put that out there. I know you guys know that, but I'm just gonna put it out there again for safety's sake. Okay. So yes, it's written in the present tense, like the discussion is also written in the present tense. So abstract. The abstract, what students tend to be kind of difficult because it's so concise. So I've given you guys pretty much a reference of how long these sentences should be. So for your introduction portion, it should be 2 to 3 sentences. That's it. Don't go overboard. And this is where concision really comes in, because you have to put the important information right there on that first page in the abstract. So 2 to 3. For the methods, you want to do 1 to 3 sentences. And for the results, 1 to 3, and the conclusions should be 1 to 2 sentences. And I would advise you guys not to copy and paste sentences from the actual body of the lab report and put it in the abstract, because it's not going to make sense. I would suggest that you guys actually read through your paper and come up with summary sentences to put in the abstract, because it has to make sense when you read it. Any questions?
Is this in any particular tense?
It follows the same tense as the body of the paper. So introduction will be present, methods will be past, results will be present, conclusion will be present. Question?
That was my question.
Okay. Same rules apply to the abstract. Okay. References, you've gone over APA style, so you guys know about that. I have a little cheat sheet. I always use Night Sight. It's quick and dirty. website you can go to, and it asks you to put in all the information, and then you press enter, it pretty much does it for you. So all the spacing, the periods goes here, and the abbreviation goes here. It does it for you. And I think this is a good tool to kind of save you time, because you can sit there forever and actually do a reference page trying to do every little rule. Okay? Questions about anything that we discussed? Yes.
About citing, when, let's say, in discussion, you're writing up an article that you use or something like that, how would you cite it?
In a discussion portion?
Or like in a lecture, would you not even include an article in there?
What do you mean? Like, how do you
Like,
cite?
is there parenthetical citation in the lab report?
No, you don't use parentheses. You use the little, what do they call them? The sub.
Footnotes?
Yeah.
Oh.
So you can look at an example in your sample article. There should be tons of references, not the very last page, but like close to the last page. And the numbers that are next to the references refer to the numbers that are in the text. You guys see that? So if it has one, then you can just go back to the reference page and see what that source is. If it has two, and it's written in order. Yes.
Okay, I guess this might be a question for Dr. Pettis, but,
I'm listening.
like when we start like as freshmen, are we gonna have like, are we expected to like notice like really well
Yes.
already?
Yes.
And, but you were saying that you, like your TA gave your lab report back to you multiple times and just said like, fix it. Like when we turn our lab in, it's just like, it's gotta be like complete as our final draft.
I was lucky to have a fix it. I think it was just so bad that he was like, it wouldn't be fair to grade you.
Yeah.
It was to that, it was really bad. I went back and looked at it the other day, I was like, this is terrible. But in college, the expectation is that you know how to do these things. Your professor is going to teach you about the subject matter. They're not going to go back and teach you how to write a paper. They're not going to teach you how to cite it. They want you to already know, day one, how to do it. If you get a C or a D or F and you want to improve upon it next time, because it may not be a redo, then you can go to that professor and ask, what did I do wrong? We also have a writing center here where you can go, before you can turn the paper in, you can go, they'll go through your paper, they'll read it, they'll mark it, and then you can do it again. You can come back as many times as you want. But the expectation is that you already know how to do this. Yes.
Okay, and so we're doing like one piece a week.
I wouldn't say a week. I just remember, I don't know how it is now, but I remember in my bio lab, we had 2 major lab reports. Every lab's not going to have a report that goes with it, but when you do have it, it's usually the expectation is like 25 pages. Because the lab may take 3 weeks. Each lab is 3 hours. It's like 9 hours of material. You should probably have 20 pages of things to discuss. So that was like the one major one, and then I had like little ones that were like in orgo or chemistry, but the expectation is the same, that it should be a complete, well-written lab report. It might not be every week, but you will have at least 1 or 2 each lab in the semester.
Okay, I just have one more. So would you recommend that you're working on different parts of this throughout the lab, or like taking notes, or like?
I would suggest you keep a really, really good lab notebook.
You have to keep a lab notebook.
Oh, you do?
You are required in every lab course to keep an accurate and up-to-date lab notebook. Those will be checked, if not every week, very often, and usually it's unannounced when they are checked. It is drop your lab notebook in the box and you'll get it back next time, and they'll go through it and check it. So lab notebooks are what you write 90% of this off of, with the exception of your introduction and a little bit of discussion. You're going to use your lab notebook for that. So how do you know if your methods are accurate? How do you know if they're right if your lab notebook isn't up to date? See, if your lab notebook is wrong and I read your methods and I know that we changed methods in the lab, but you gave me the old methods, I know your lab notebook now sucks too. I've got both of those already pegged and figured out. I know your lab report's not any good, and I know your lab report is and your notebook is messed up. It all follows. We were students too. Yeah.
What all should be like in our lab?
Everything.
Yeah.
I cannot tell you how many times I got to my computer and I didn't write down how many meters something was.
Mm-hmm.
So now I can't put that. I'm like, I know it's between 16 and 20, but I don't know how many, everything. Colors, what something did, your measurements, how much something weighed, everything. Unit. Nice. Is carbon copy. So each page is carbon copy. And instead of you turning in your whole notebook each week, at the end of lab, you would tear out the pink copy and you'll staple them together and you'll turn it in. So you can't go home and like fix it real. No.
Nope.
They want it that day.
That is another rule about lab notebooks that you need to know and understand now. You never ever take something out of your lab notebook. Ever. Ever, ever. I don't care if you mess up a page and it looks like crap. You put an X through it and you just use the next page.
Yeah, they want each page. And they're numbered so they can tell if you this kind of ignored page 18 to 20. They want all those pages.
There are very big professional rules about how a lab notebook is to be kept. So you're learning that now. And that's what they expect you to learn. And that's one of the big rules is that in industry, if something is missing from your lab notebook, that can mean millions of dollars in patents that your company might have lost. Same thing with patients, things like that. You never ever take anything out of your lab notebook.
Are certain professors or TAs, do they have their own policies on how to keep notebooks, or are they basically
They do.
It's basically the same.
Okay.
Yeah.
And, in bio, I think I took that before I took oral lab. So she
Learned it the
wanted
right
us to draw a line down the middle of the page, and then to the left of the line, you're gonna write your, you're gonna rewrite the procedures from the lab notebook. And then on the right side, you're gonna take your own notes when you're in lab. And they expect for you to actually do it before. I would say like lab is only once a week. So I would suggest that like maybe a whole week before that lab starts, start writing down your procedures, start trying to understand what it is you're going to be doing in lab. Because A, it'll go by much faster, and B, you don't want to wait till the night before to write those things down. You get there, you don't understand it, and you're just wasting time and materials. And your lab partner's going to be really upset with you. Been there, done that, plenty of times. Been on both ends.
Yeah.
So, yeah, I mean, lab is once a week, and it seems like it's like only a percentage of your grade, or it's a small credit class, but it takes a lot of effort.
At Georgia State, and I'm not exactly sure how it is here, but the lab for my class, for my intro bio, is 25% of your final grade for the course. That's significant. I've had students that have aced through the lecture, but I have to give them a C because they really did really badly in lab.
And I have to say, here at Emory, I've experienced the opposite. They've been just, students have not done well in their lecture component of the course, and their lab has saved them. So your lab will save you in your biology and chemistry.
It can.
Here. I've experienced the total opposite. I've been here 16 years, and I've seen students really almost about to flunk biology and chemistry, and their lab has saved them. Your lab grade is going over.
So if you fail the lab, you fail the class. Just remember that.
Right.
Yeah.
And the side of reality for here, at this institution, if you fail lab, you fail the class.
It doesn't matter how many A's you made. If you fail that lab, you're done. They're not going to even address the other grades you have.
And your grade for lab is usually based on your lab reports, your lab notebook, and participation. Well, participation is subjective, so that one creates a problem. We should talk about participation at some time. But then your lab notebooks and lab reports, that's what's going to save you. That's what's going to help. So remember these rules.
Yeah, I just want to say I didn't have anyone telling me about the importance of labs, so I had to like land on my face a few times to realize, well, this lab thing is kind of important. It's really important. I take it very seriously. So let's see. We have about a few minutes, so I'm going to go over how to read a scientific journal, and then for your homework for the week, I'm going to ask you guys to read the one that I've given you and come back and we'll discuss it. Fair enough? Okay. Okay. So when you're reading a science journal or when you're so the important part of the paper is the abstract, and you guys pretty much know what the abstract is now. It's that very short blurb. Sometimes it'll be labeled abstract, sometimes it won't. It'll just be that first thing you see in the journal. And the important thing is to read the title of the paper. Read the title of the paper, and you can pretty much gather from there if it's something that you're interested in or not. In this case, you can't really choose, but the title will give you a big clue on what the paper is about. And it's usually long and drawn out, so you can pretty much gather information from the title. Read the abstract in its entirety. It's going to be very short and simple, but it gives you a good glimpse on what the article is about. And try to read the purpose. Sometimes the purpose is kind of stuck deep into the introduction or sometimes in the abstract, but look forward to see what the author is trying to figure out and what the author is trying to find in the experience. So, do your own research. These journal articles can be very, very dense and be very, very intimidating. I've been reading these things for about 5 to 6 years now, and I still have to take several days to read one article because there's so much information. There's no shame in it. It's hard. Take your time, read, and do your own research. So use other sources to define unfamiliar terms or concepts, and you need to do this as you read the entire paper. And when you read the paper and if things don't quite pan out for you, then write the questions. The paper is yours. On the back, you can write notes. I personally write all my notes in colored pencils or colored ink because it's fun and it keeps my attention. And as you guys go through college, you'll find your own note-taking skills that kind of keep you attentive. But that's kind of my thing. So everything is color-coded, or I write in pink because it's happy, because this art makes me sad. It's my thing, whatever, no shame. But make sure you write notes as you read the article. When you're doing your own research and you need to define things that are unfamiliar to you, you need to use valid sources. And you need to write those definitions down so you always have a reference point for that definition. And don't get too caught up in the details. So when you're reading a journal article, it's not for you to understand every single last bit of that article. They put that in there for different reasons, for funding or for further research, or for proposals. For you as just a regular reader, as a student scientist, you pretty much want to read the entire paper, but you don't want to know every single last detail. To kind of get a good gist of what the paper is about. Is that fair? Okay. So, the introduction gives background information about the topic, and you will find that it's probably the easiest portion of the paper. If you ever have to do your own search for a paper and you go through the introduction and you can't read it, then fail, because most of the paper is going to be harder than that, okay? The introduction is usually written in the simplest form, so if you can't read the introduction of any paper, don't read that paper if you can avoid it, because it only gets harder from there, okay? All right. And the introduction pretty much gives what's already known about the topic, or we already know past research that has been done, and what you want to do to contribute to this topic, or what the author wants to do to contribute to the topic. And it gives a sense of why the author is studying the subject matter, so it pretty much gives the purpose. Okay. Reading the methods and materials. So if it has subtitles, lean on the subtitles. They'll give you so much information and kind of guide your reading. Like I said, your goal is to read the entire paper, but you don't want to get too bogged down in the details. So if you see something that's labeled statistics, you guys haven't had that, you probably won't have it for a long time. I wouldn't pay that much attention to it at your stage. At my stage in pharmacy school, statistics is everything. It's everything. It's more important than the method sometimes. But for your purposes, I wouldn't really worry about it, okay? And read all that you can understand. And for you guys, I want you guys to read the entire thing and bring your questions to class, okay? And I'll try to clarify some of those questions. All right, so when you read the results, I would say focus on the graph and read the text. The graph is really much is gonna tell you what they found. Like I said before in the past presentation, these papers tend to have tons and tons and tons of graphs. And when you're reading these things, it's easier to just read the graph and refer to the text versus reading the text and referring to the graphs. Okay. All right, discussion. The discussion part of the paper is the most important when you're reading the paper because it pretty much gives you an explanation of the big picture. So, like I said before, the goal is to read the majority of, well, the entire paper, but this is the section that you really want to pay the most attention to. Okay? It gives a scope of how the study links to the background information, and the conclusion is often included in this section. If you've noticed, I haven't had a separate section called conclusion. We really don't do that in science. The conclusion is way more difficult than just a few sentences. And it's usually pretty much a discussion. It's pretty much tucked in that section. Okay? And the author usually describes how the study supports the conclusion. It also discusses future goals, the importance of the study, surprise findings, et cetera, and it's pretty much the portion of the paper that brings the experiment full circle. It's more the holistic portion of the paper. Okay. So, yeah. So what I want you guys to do is to read this article, and I also want you to bring your questions and your notes. I want to see if you actually wrote notes on this paper. And I also want to see your critiques. So with you guys being a science student, you don't know everything, but you know a little bit of something, right? So it's important to you to critique science that you read, because just because it says science and it's in black and white doesn't make it true. It doesn't make it law. So I want you guys to take your time, read through it, take notes, do a little research, clarify your misunderstandings, bring questions, analyze it yourself, put your own perspective on it, come ready to discuss, and critique the study. Okay? Any initial questions about reading this lab report or this scientific journal article or about the topic at all? It's pretty simple. My high school students read it. They did a report on it, so I know you guys are like more than capable of doing this.
Can I add part of an assignment?
Oh.
So in the introduction, I want you to write down any words that you don't know the definition to off the top of your head. You can keep that list with you. And we'll talk about that next Monday. Do we have you again? Next Monday. So that's the other part of your assignment.
Any other questions, comments,